Hello, geometry students. We're here in maybe there we go. We are in section 8-4, and we do have some new vocabulary. Let me pop this up real quick. There we go. So my new vocabulary for this section is trigonometry. We have trigonometric ratio. We have the sine ratio. We have the cosine ratio. We have the tangent ratio. We have the inverse sine, we have inverse cosine, and then we also finally have inverse tangent. All right, so let's look at the trigonometric ratios of right triangles. All right, so if triangle ABC is a right triangle, and with an acute angle A, then the sine of angle A, written as sine A, you notice it's not with the E on the end, just SIN. Now I'm looking for my little marker here. It's not showing up here. Oh, there it is. Okay. So we have then sine of A. It would help if I plugged in my pen in. There we go. No wonder I couldn't do it. So we have sine of A. And sine of A is the sine of the angle A is the length across from it, which is called side A, small a, which is actually the length of CB. So side A divided by sine C, okay, which is the hypotenuse. Okay, so in sine, it's the opposite side from the angle A divided by the hypotenuse length, and that's called the sine ratio. Cosine of A is the adjacent side to A. So adjacent does not mean across, it means next to. So here's the side next to, so we have B divided by C. So we say that's the adjacent over the hypotenuse. So we have sine being the opposite divided by the hypotenuse. And we have cosine, oops, that's a C, not a G, as the adjacent side divided by the hypotenuse. And then finally, the tangent ratio. Tangent ratio is the opposite side over the adjacent. So in that case, it's going to, so we don't use the hypotenuse. It's going to be the opposite side A divided by the opposite side of B. That would be the tangent of A. So tangent is the opposite side of the angle divided by the adjacent side. And a way to remember this is the three letters here. S, C, and T represent the sine, cosine, and tangent. And there's like a little phrase here. It says SOHCAHTOA. Okay? SOHCAHTOA. And that's a punchline to what do you do when you drop a bowling ball on your foot? You SOHCAHTOA. Alright. Next one. We're going to express the sine of angle L as a fraction and a decimal to the nearest hundredth. Okay. So angle L being here. Okay, back down here again. Here's my angle L. Okay, and we are representing sine. Remember, sine is SOH, S-O-H, opposite over hypotenuse. So the opposite side is 12. The hypotenuse side is 37. So in fraction form, it's going to be 12 divided by 37, and then you can use your calculator to divide that. So as a decimal, use your calculator, take 12 divided by 37, and you get approximately 0.32. Okay. Now we're going to try and find cosine of L. Well, again, it's the same angle. And we remember Ka, C-A-H, SOHCAHTOA. So there's my cosine, and there's my adjacent over hypotenuse. So the side length that's adjacent to L, obviously it's not the 37, that's the hypotenuse. The side next to L is 35, and then the hypotenuse is 37, so we have 35 over 37. Okay, and so we express that as a fraction. or also as a decimal. Okay, now we're going to do tangent of L. Well, tangent of L, if you recall, tangent is TOA. T-O-A. Opposite over adjacent. Now you got to remember, when we say opposite over adjacent, it's opposite and adjacent of a particular angle. So we're doing of angle L. So we're finding tan of L, tangent of L. So opposite would be 12. So this would be 12. And my adjacent is 35. So we can say it's 12 over 35. Now, tangent can also be represented as sine over cosine. Sine divided by cosine. So sine of L divided by cosine of L. So sine would be 12 divided by 37. Cosine would be 35 divided by 37. And when you take a fraction divided by a fraction, you take the first fraction and you multiply by the reciprocal of the second fraction. And the 37's cancel, and you still get 12 over 35. So you can actually find the tangent based on the ratio of sine and cosine. Or just remember that tangent is TOA, of the word SOHCAHTOA. And then to find the decimal, just divide 12 divided by 35, and your answer then being about 0.34. Okay. Now we're going to express, it's going to be the same figure, but we're going to express sine of n as a fraction as a decimal. So n's up top here. So this time we're looking at not angle L, but angle n. So everything that we said like across or adjacent to and all that is going to switch. So sine of n is the opposite, okay? So sine of n is going to be the opposite side, 35, divided by the hypotenuse. So we'll go through this a little quicker. Okay, and then if we're going to do cosine of n, remember cosine is, but it's specific to the angle, right? So adjacent, this time 12 is adjacent, where last time 35, right, was adjacent to L. So this time the cosine of n is going to be 12 over 37. And same as, so if you notice that the actual sine and cosine values between these two angles are actually just switching. And then finally the tangent is going to be the exact reciprocal ratio. This time it's going to be tangent of n, which is going to be opposite. Right, so opposite's 35, and then adjacent's 12, so 35 over 12. Where the tangent of L was 12 over 35. Okay, check your progress. You're going to try to find the sine of angle A. Go ahead and pause your video. Good, if you said 3 over 5, you are correct. That's the same thing as saying 12 over 20, and we divided by 4 up top here, and divide by 4 on the bottom, get 3/5. Okay, check your progress. You're going to find cosine of A. Go ahead and pause your video. Good, cosine of A is going to be 16 over 20, which reduces down to 4/5. And then finally, check your progress. You're going to find tangent of A. Go ahead and pause your video. Tangent of A is 12 over 16. That would be the opposite side over the adjacent side, 16, 12 over 16, which reduces by a factor of 4 into 3/4. Okay, now you're going to find sine of B, okay, with the same triangle. Go ahead and pause your video. Sine of B. Good, if you said 16 over 20. Do you notice that's the same answer, right, as the cosine of A? Okay, so go back and look at cosine of A. See, it's 4/5 cosine of A is equal to the same thing as sine of B. Okay, now you're going to find cosine of B. Go ahead and pause your video to find cosine of B. Cosine of B is the same thing as sine of A. Cosine of B, same thing as sine of A. So 12 over 20, right? Or 3/5 by a reduction of division of 4. All right, and finally you're going to find tangent of B. And tangent of B is going to be the exact reciprocal. So it doesn't switch, obviously, it's going to actually flip. So tangent of B, instead of being 12 over 16, it's going to be 16 over 12. 16 over 12. So think about that. 16 over 12 is an improper fraction, and D is the only one that's an improper fraction. All right, so now we're going to use special right triangles to find trigonometric ratios. We're going to use a special right triangle to express the cosine of 60 degrees as a fraction. Remember the 60-degree one in a right triangle. So we can draw and label the side lengths of a 30, 60, 90 with the x and the 2x as the length of the hypotenuse. And then we also have then the x root 3, right, as my height of it. Okay, so then we're going to find cosine of 60 degrees. Well, based on that, right, we're going to be able to say that cosine 60 is going to be the adjacent side x divided by 2x. So it looks like x divided by 2x. It looks like the x's are going to cancel, but when you cancel and you have nothing left over, obviously you put a 1. So it looks like cosine of 60 is going to be a half. So if you know your special triangle, you should be able to figure out the cosine angle. All right, so we have cosine 60 again equals the adjacent of the hypotenuse. We have x over 2x, and then we can reduce it down to a half. Good. Answer 1/2 or 0.5. Okay, now we're going to use special right triangle to express the tangent of 60 degrees as a fraction. Check your progress. You could pause your video if you like. All right, so let's go ahead and show you it's going to be square root of 3 over 1 or square root of 3. And we can go back and we can look at why that is. We're looking for the tangent of 60. Let's go back to that picture. So tangent of 60. Okay? And the tangent of 60 is going to be the opposite side, x over root 3. Okay, x times root 3 divided by the adjacent side x. Now this time the x's cancel and you get 1, but this time you get square root of 3 on top. So how about just root 3 as the answer for tangent of 60? Okay, now we have a little real-world example. And it says a fitness trainer sets the incline on a treadmill to 7 degrees. And the walking surface is 5 feet long. And we want to figure out approximately how many inches the trainer raised. So we're going to try to figure out the y. So that's how much they've raised the actual treadmill, right? So what we have here is related to the 7 degrees. We're looking for the opposite side, but we know the hypotenuse. Remember, the hypotenuse always comes across from the 90-degree angle. So what we can say basically we can say sine of 7 degrees. And that should equal the opposite side y over 5. You can multiply both sides by 5, and you get the y value, right? You get the y value to be 5 times sine of 7. Now sine of 7, you aren't needed to or aren't expected to know what that is exactly, but you have a scientific calculator, or your graphing calculator can find the sine of 7 degrees. Just make sure you're in degree mode, right, when you use your calculator. So 5 times sine of 7. Okay? So we have sine of 7 equals y over 60. Oh, I made a mistake. They changed it to inches because it wants to know how many inches. Right? Now, we could have done 5 times sine 7, and that would have gave me an answer in feet. And then I'd have to convert that answer by division of 12. So, by multiplying by 12, because we wanted inches. So instead, we convert to 60 inches first, so you get 60 sine 7. Okay? So multiply each side by 60. Use a calculator to find y. Right? And there's your 60 sine 7. Enter, basically. If you're using your scientific, make sure you're in degree mode. Most likely you will be, 7.312. All right, here is an example for you to try. The bottom of a handicap ramp is 15 feet, right? And the angle is at 4.8. How high does the ramp rise? Now, what do you know is this time is we are looking for this side, and we don't have the hypotenuse, we actually have the adjacent side. So if you don't have the hypotenuse, you cannot use sine or cosine. So go ahead and pause your video to see if you know how to solve it. I'll give you a hint. You're going to use tangent. Okay, you've got an answer of 15, approximately 15. Let's see why. So we're going to have our statement here of tangent. Tangent of 4.8 degrees is equal to the question mark, right, over 15. So we can solve for the question mark by taking 15 times tan of 48, or 4.8. Now I assume tangent of 4.8 then must be somewhere. Oh, I did it again, didn't I? 15 feet, and we want inches again. So once we get this answer, we can multiply by 12. Okay, and that should give us somewhere around 15. Okay, or we can convert this 15 into inches right now by multiplying by 12. So either way will work. This will give me a feet answer. So let's go ahead and pause our video and try this with a calculator. Okay, this ends up being about 1.25 feet. And then when you multiply 1.25, right, times 12 inches, you get 15. All right. Now, inverse trigonometric ratios. Okay, this is actually going the opposite. What it says here is if angle A is an acute angle and the sine of A is x, then the inverse sine of x is the measure of angle A. So, if sine of angle A is equal to x, then the inverse sine of x is equal to the measurement of A. But only, again, like they said, if A is an acute angle. So make sure it's only an acute angle. Same thing with the inverse cosine. If cosine A equals x, then inverse cosine of x equals the measurement of angle A. And then if tangent A equals x, the inverse tangent equals the measurement of angle A. Okay, we're going to use a calculator to find the measure of angle P. So what do we have there? Okay, we have the relative to P, right? We have 13, which is the adjacent side, and the hypotenuse. So we're going to say cosine of angle P is going to equal 13 over 19. Now, using that, we could use the inverse cosine of which is indicated with a little -1 there, right? Of 13 out of 19, and that should give us the angle, measurement of the angle. So get your calculator out. Let's hit inverse cosine. Okay, usually it's a second command, inverse cosine of 13 divided by 19. And you get an answer of about 46.83 degrees. All right, let's see how they solved it. Okay, so there it is. Then they use inverse cosine then. We use a calculator. And 46.83. I said 0.83. I rounded to the nearest hundredth. So the measure of angle P is approximately 46.8 degrees. Okay, now you're going to check your progress, and you're going to find the measurement of angle D to the nearest tenth. Go ahead and pause your video. Okay, if you said 44.1 degrees, so what we have there, right, in our statement, is that we have we have of D, so we have the opposite, so we're using sine, so sine of angle D is going to equal 16 over 23. Therefore, we can find the measurement of angle D, or measurement angle D, by doing the inverse sine of 16 over 23, which gives me a measure, and you can use your calculator, inverse sine of 16 divided by 23. And you get an answer of 44.079, which they rounded to 44.1. Okay. In the next one, we have a right triangle. And we're going to, it says solve the right triangle. Oh, round side measures to the nearest hundredth and angle measures to the nearest degree. Okay. So what we can do here is we could find the angle A here by doing inverse tangent. So we can do inverse tangent of the ratio, right, of 4 over 7. And that's going to give me then the measurement of angle A. So let's do that. I have inverse tangent in my calculator, 4 divided by 7, as what we're taking the ratio of, and I get 29.7. Now it does say round angle measure to the nearest degree, so that would be 30 degrees. So we'll call this 30. If we call that 30 degrees, up in here, right, 30 degrees, then this obviously has to be 60. Okay? And this ends up being a 30-60 right triangle. So my hypotenuse should always be double the smallest side length here. So this should be an 8. Okay, let's see what happens. So we round to 30. Measurement B must be then 60. And then we have a 30-60-90 triangle. I guess we have to do it that way. Or we can just say the fact that we know that the hypotenuse is always twice the smallest length. And they round to 8.06 or 8.1, looks like, I believe. Oh, to the nearest hundred, so 8.06. So I just use the measurement, which is good. Either way would be okay. Okay, now we're going to try to have you guys solve the right triangle and check your progress. Let me lower this. You can see that last possible answer there. Maybe that's the right one. Okay. Go ahead and pause your video. Alright, so if you said that you thought it was going to be B, you are correct. So, how do we do that? Well, we can take the, again, it's going to be inverse tangent of 8 divided by 11, and that gives me my angle B, 36 degrees. So we know angle B has to be 36. And if angle B is 36, okay, then the answer only could be B, right, or D, it looks like. And angle A has to be complementary to it, so it has to be 54. Right, so those match. The only thing is side length AB looks like has to be 13.6, and we can do that by using the Pythagorean theorem. Okay, so we have 11 squared plus 8 squared should equal the AB squared, or we'll call that side length C squared. And then we take a square root to solve. And then we use a calculator of the square root of 11 squared plus 8 squared. Again, answer of 13.601, or about 13.6.